keep putting in our labels. And once again, we've regenerated our base catalyst. This doesn't look like a carbonyl anymore because it's totally lost the carbonyl oxygen, which is left like this. And then this gives us our final product here. We should be able to figure out what the name for that is, but also the handout reminds us here that the product is the alpha-beta unsaturated ketone. Now again, that should be a logical name, alpha-beta unsaturated ketone, because there's the unsaturation between the alpha and the beta carbon here. So this is the product under hot conditions. And this would have been the product under cold conditions. So it's important to be able to understand how to use the handout if you get stuck. On the other hand though, it's also important just to understand the basic logic of what's going on here. So what's the basic logic of what's going on here if we follow our model? What's going to be happening is, again, the alpha carbon is going to be nucleophilically attacking the starred carbon. The alpha carbon is attacking the starred carbon. Well, so the pattern is make an enolate, and then the alpha carbon, so make the alpha, deprotonate the alpha carbon, and then the alpha carbon attacks the starred carbon. Notice that that's what happened first here. We deprotonated the alpha carbon, and then the alpha carbon attacked the carbonyl carbon. And then that would give us a category 1 attack. What about if we want to do a category 3? Well, we just do it all over again. Deprotonate the alpha carbon, and then the alpha carbon attacks the starred carbon. So it's important to see that this category 1 and the category 3 is just the same thing that happened in category 1 done all over again. So we'll just look at it one more time. You deprotonate the alpha carbon, and then the alpha carbon attacks the carbonyl. That would give you the category 1 product. And under hot conditions, you just do those same steps all over again. You deprotonate the alpha carbon, and then the alpha carbon attacks the carbonyl carbon. Of course, it doesn't look like a carbonyl anymore. That's why we put in the star to help us remember that. So in both cases, the alpha is attacking the star. First, the alpha deprotonates, and then it attacks the star. Then under hot conditions, the alpha deprotonates again, and it attacks the starred carbon again. So we were seeing here how to do a intramolecular aldol condensation. We went over some techniques for using our finger to count how many atoms would be in the ring and using numbers to label everything. This certainly is a topic that's very likely to be on the test. It's pretty standard material. It would be a good idea to mark this problem and go back and try it again, because that was a challenging problem. It was. Well, let's try another problem where we're trying to predict the product, but we'll go through the full mechanism here. Here's our starting materials, 2 equivalents of phenylacetaldehyde, and we'll try to show the mechanism and the products under both cold and hot conditions. So let's see if we can draw what the first step would look like. Let's talk about that first step. Your first step was a good one, which was just to draw the structure. We can't work with a name, we have to draw the structure. Now, we know it's going to be an aldehyde. What does acet mean?
2.
2 carbons.
Yes.
And what does phenyl mean?
It's a benzene substituent.
That's right, a benzene substituent. But we don't actually need to draw the benzene. You used a good trick, which is just to write pH. However, I think that you actually didn't put in the second carbon here. You might have written it like this. I guess this would be phenylformaldehyde.
Okay.
This would be phenylformaldehyde. This means the phenyl is a substituent on these two carbons. We're not counting the phenyl as one of the carbons. That was a little tricky, but it's good that you tried to draw the structure, and it's good that you used pH as a good abbreviation here. And something else that you did that was good is you went ahead and wrote two different versions of this. You saw that we were going to need that. Well, let's continue.
So this is my product for cold.
Okay, well, you're doing real well. You're doing fine. You can continue. Let me just point out that I think you might have left out this arrow here. When we deprotonate the alpha carbon, we need to show that it's gaining the electrons. That's the whole purpose of the deprotonation, to give it those electrons. Otherwise, looks like you're doing good.